So in example 5, we have our very first composite surface area problem. And the biggest thing to remember when you're doing composite surface area is that you are finding the sum of all of the areas of the exposed surfaces. So in this figure right here, we are not getting the area of the top of this rectangular prism, this box that we have on the bottom, nor do we want that rectangular area of the face um, of that triangular prism. Okay, so we're adding together just the areas of the exposed surfaces. So let's start with this bottom box here. We have 5 of the 6 faces exposed on the surface. They are this bottom one, and then the left, the front, the right, and the back sides. So I think a good place to start for us would be to get the lateral area of this bottom box. And remember that the lateral area is found by perimeter of the base times the height. So the perimeter of the base, in this case, we have 4 plus 2, plus this back edge is also 4, and the left edge is also 2. And then the height is 3 centimeters. So we'll multiply these together. 4 plus 2 is 6. We've got 2 of those. We're at 12. 12 times 3. So we're looking at 36 square centimeters for that lateral area. Now we need to add on the area of this bottom face. Okay? Again, there's no top face that's the same as that. So this bottom face is just a rectangle with dimensions of 4 and 2. So 4 by 2 multiplies to give us 8. Okay, off to the right side here, we'll keep track of these individual areas that ultimately will add together to get this full surface area at the end. Now, we've taken care of the box, okay? 5 of the 6 faces, not that top face, and that means that we only have this triangular prism remaining to consider. Let's start with the front and the back faces, which are actually the bases of these of this prism. We see that it's a triangle, a right triangle, with a height of 3 centimeters, and this base edge length is going to be the same as this 4 centimeter part that we saw on the rectangular prism. So, area of the triangular faces. We know area of a triangle, 1/2. Base length is 4. Height is 3. And we have 2 of these. Okay, the front and the back are going to be congruent to each other. So really the 2 and the 1/2, they multiply together to give us 1. So our answer is just the 4 times 3, or the 12 square centimeters. And we have 2 remaining faces to consider. Coming back here, we have this left side that we see has a height of 3, and this distance right there that's connecting the 2 bases, okay, that's going to be the same as this in this rectangular prism, which we can see is also the same as this 2. Okay, so again, we have a rectangle with an area 3 times 2, or 6 square centimeters. And our last remaining surface is like the surface that's made from the hypotenuse of this triangular, these triangular bases and this triangular prism. So you see that's a rectangle. We know that we just found that this height of the rectangle is 2. For this hypotenuse distance, we really need to use the Pythagorean theorem. We've got 3 and 4. Oops. 3 and 4. So we know that this is a 3, 4, 5 Pythagorean triple. So we'll get the area of that rectangle. 2 times 5 is 10. And we need to add up all of these individual surface areas to get this full, complete composite area. Okay? So we have those values together. We can do 36 plus 8 plus 12 plus 6 plus 10, giving us a total surface area of 72. We do want to put units with our final answer, square centimeters.